Humus is a component of the soil which is extremely important for soil texture, the absorption of water and nutrients, and for plant growth in general. Humus consists of a heterogenic mixture of organic molecules. It is formed by the decomposition of dead plant material. The determination of the humus content starts with the sampling of the soil. It is always necessary to take several samples from each habitat in order to get a meaningful average value. The position of the sampling site is exactly recorded, for example with a GPS. Before analysis, the moist soil is dried at 70 degrees centigrade for several days. Only the fine soil with a grain size smaller than 2 mm is used. Pebble stones, roots, and other coarse particles are removed by sieving. Already with the naked eye, it is visible that the sandy soil on the left contains less humus than the black soil on the right. For the quantification of humus, 1 gram of the dried and sieved soil is weighed into flasks. Furthermore, a series of Meyer samples is prepared for calibration. 0, 116, 232 and 348 milligrams. Now, all these samples are treated exactly in the same way. Humus is quantified by the reaction with potassium dichromate. The humus is oxidized to CO2 and water, and the dichromate anion is reduced to the chromium 3 cation. Potassium dichromate is a crystalline orange powder. It is a strongly oxidizing agent, but it is also highly toxic and causes cancer. Therefore, it has to be handled with greatest care. We prepare a 0.3 molar solution of the dichromate in water. The solution is virtually saturated and will require some time to dissolve. Exactly 20 milliliters of the dichromate solution are added to each sample. Always use a pipette ball. Never use your mouth. So far, nothing happens. The reaction requires the presence of protons. Therefore, we have to add a strong acid as well. We use sulfuric acid for acidification. Sulfuric acid is a very strong and aggressive acid, which may cause serious injuries. Be careful and always wear your personal protection. We add 15 milliliters of concentrated sulfuric acid to each sample. During the reaction, the sample becomes very hot and may start to boil. Add the acid only dropwise and allow some time for cooling if necessary. Always work in the fume hood and do not direct the opening of the flask towards you. The reaction may require up to 6 hours. After that time, the flasks are filled up with distilled water to 100 milliliters and left to rest overnight. After completion of the reaction, the orange dichromate has been partly reduced to the blue chromium-3 by oxidizing organic compounds. The intensity of the blue color is a direct measure for the amount of organic compounds in the sample. Here, the calibration series can be seen with colors ranging from orange to green and blue. It is clearly visible that the sandy soil produced less blue chromium cations than the humus-rich soil. For a more exact quantification, a spectral photometer is used. This instrument measures the absorption of light by a sample at a given wavelength. For the detection of chromium-3, a wavelength of 570 nanometers is used. We start with the measurement of the Meyer inositol series for calibration. At the y-axis, the original weights of the calibration series are shown. On the x-axis, the light absorption of the photometer is plotted. All measurements of the calibration series lie on a straight line. The light absorption of the calibration sample containing 0 mg Meyer inositol is the same as for a humus sample containing 0% humus. The light absorption of a sample with 116 mg Meyer inositol is the same as for 2% humus, and so on. Now we measure the absorption of the soil samples. Soil sample A causes an absorption of 0.6 at 570 nanometers. This corresponds to a humus content of 1.6%. Soil sample B contains 5.2% humus. After the measurements, the chromium solution is still toxic and corrosive. It is collected and disposed professionally. Data on the humus content of the soil help to answer many questions related to fertilization, land use, and soil remediation.